Mathematicians tend to like to write things in the simplest or shortest way possible. Here's some examples. We have 3 plus 2, but we simplify it to 5. Here's a fraction problem. 1/4 plus 1/2 gets simplified to 3/4. Much shorter than the original problem. Here's a fraction 9/12. It's equal to 3/4, but the 3 and the 4 are smaller numbers. Mathematicians like it that way. So we like to write 3/4 instead of 9/12. It's called putting the fraction in lowest terms, sometimes called simplifying the fraction. Here's an expression. It can't be simplified right now. We don't know what A is. We don't know what B is. Things separated by additions and subtractions in expressions are called terms. This expression has 3 terms. This expression also has 3 terms. And so does this one. But this one has something special. While it has 3 terms, 2 of the terms are called like terms. So this expression can be simplified. The 2 terms that are like terms are marked with the red marks, the 3a and the 5a. And since a is the first word in apple, we can think of this as 3 apples plus 5 apples, which of course is 8 apples. So we simplify this expression to 8a take away 4. Here's a more formal way to show it. We apply the definition of subtraction. We do that because we're going to use the commutative property. And the commutative property does not apply to subtraction. So now that we've rewritten it as an all-addition problem, the commutative property allows us to reverse the 5a and the negative 4. And then the associative property allows us to group the 3a and the 5a to get 8a plus negative 4, but it's often changed back to 8a take away 4. Another way to explain it is to use the distributive property shown here. Well, if this is true, that a times the quantity b plus c is equal to a times b plus a times c, we know it's also true that we can reverse that order and write that a times b plus a times c is equal to a times the quantity b plus c. This, of course, is known as the symmetric property. Well, that's what we're doing here. We're starting with 3 times a plus 5 times a, and we're going to apply the distributive property in reverse order from the way we first learned it by writing this. A times the quantity 3 plus 5, also known as a times the sum of 3 plus 5, we of course get 8, and then a times 8 is more commonly written as 8a. You don't need to show this work every time you do it, but when you combine like terms such as these two, you're applying the distributive property when you do. Here's a slightly longer problem. Let's find the like terms shown here. This is a method of showing our like terms, and if you only have one color, you can use a single mark for one type of term and a double mark for the other. But I have more than one color, so I use 2 colors and 2 types of marks. A bit of overkill, but that's okay. So all of the A's go together, and we write them on the left, and the 2 and the 3 go together on the right. We combine our like terms by associating with the associative property, and then we get 12a plus 5. We don't usually show all of that work because most of it can be done mentally. So here's another problem, but we have some b terms, and we notice that the 2 has no like term to combine with, so we mark the 2 b terms that are like terms, the 2 a terms. We combine the 3a and the 4a, and then the 5b and the 3b, and we started with 5 terms, and we ended up with 3. We showed a little bit of work by identifying our like terms, but the rest of the work could be done mentally, so we pretty much got this problem simplified in 2 lines. Here's another problem, and what's different about this problem is the a all by itself with no coefficient. But first we mark the like terms, and we see that we have an a and a 4a and a 2 and a 3, and the 5b doesn't have anything to combine with. But then we remember that since 1 times a is a, then a is equal to 1a. So to help us remember, we put a red 1 next to the a. It's not necessary, but it reminds us that an a is the same as 1a, so even though we don't normally write the coefficient, we can if we want, and it's a 1. So 1a and 4a is 5a, The 5b comes down because it didn't combine with anything, and 2 plus 3 is 5. And this expression is now simplified. Here's one, and instead of a 2 and a 3, it has a 2ab and a 3ab. Well, the combined ab might as well be another letter, because ab does not equal to a except in special cases, and ab is not equal to b except in special cases. So we can't consider any of them like terms with the a's or the b's, but they are like terms with each other. So we mark them up as shown, and the 2ab and the 3ab go together. The 5b and the 4b go together, and the a comes down. It had nothing to combine with, and we've simplified another expression. Here's an expression with exponents, and a reminder that a to the second is also known as a squared, and a to the third is also known as a cubed. But except in special cases, a does not equal a squared, which does not equal a cubed. So we can't combine those. But we can combine a 4a squared and a 3a squared, and a 1a and a 4a. So we do as shown, and we get the answer in the second line. It's often customary to write in what's called descending order of the exponents, but that's not mandatory, so either of those bottom two lines are fine simplified answers for the top expression. Here's one that involves subtraction, so the first thing we're going to do is apply this definition of subtraction. And in order to do that, we needed a slightly smaller font to fit everything in. Then we mark up our like terms, then we combine those like terms, and we get a plus negative 1ab plus negative 9b. It's customary to drop the 1 and just have a plus the opposite of ab plus negative 9b. And it's also quite common to change it one more time to a take away ab take away 9b. Here's a really long one. We've lowered the font size yet again, and we're going to apply the definition of subtraction. And notice right in the middle we have a special case. Doesn't come up so often, but it's subtract a negative 3a. And we're going to change that to add the opposite of negative 3a, or add 3a. So now we've applied the definition of subtraction in several places, and we've also decided to mark the a with the red 1 as a reminder. And by applying the definition of subtraction, we end up with plus negative 1a. Then we use 3 different colors to mark our 3 different types of terms. We have a's, we have b's, and we have some numbers. But first we notice that the negative 2b and the positive 2b are opposites. So instead of going to the trouble to write 0b, we take a shortcut and we just mark them out. It's not a formal way to do it, but it works, and it is showing a little bit of work as to why we don't have any b's in our final simplified answer. So now we just have numbers and a's, and we combine those, and it's quite short at the end, 7a plus 1. To summarize, when simplifying variable expressions, look for like terms, then combine like terms.